Okay, let's just go get and started. Um, so today we're just gonna go over a few example algorithms in QuantConnect. Okay, so I already went over this in the last workshop, but let's go over some reasons why we use QuantConnect. So the first reason is that it's basically almost all free. You can do anything like the back testing, notebooks, just basic almost everything in QuantConnect. Like you can just do for free. The only thing that will cost money is if you wanted is if you wanted to deploy your algorithm live to like some to the server. And okay, okay, another reason is that we have pretty good relationships with them. Like UW, like just proximity wise, it's really close to QuantConnect, and we've had some UW students go intern and work at QuantConnect. And another reason is that it's probably one of the better platforms. Like Quantopian dead. I think they're coming back alive or something. Like they got bought out, but QuantConnect is just growing. Okay, so let's just go over the first strategy. So let's just have a simple moving average crossover strategy. Hopefully by now everyone knows what a simple moving average crossover is. Okay, so let's just do like SMA like 5 equals self dot SMA. Okay, so self dot SMA is a method. Oh, oh, there it is. Okay, so you can. Oh, it's actually not. Is it here? Okay, right here. So it creates an indicator. Like if I like type something and you don't understand what it is, or if you're like looking through the docs and you don't understand what a method does, most of the methods you can find by going to like the API tree, which is on the right, the second button down. Then you just type in. So let's just create a simple moving average indicator. So let's do for SPY 5, and then like resolution.daily. And then let's self.SMA 20 equals self.SMA SPY. Then let's do 20 and then resolution.daily. And let's just set the self.automatic indicator warm up equals true. And what is this Boolean? It is a Boolean that belongs to the QC algorithm class. And when we set it to true, the QC algorithm backend knows to warm up all the indicators we have here. Okay, so let's just have our logic. So if self.estimate 20.current.value is greater than self.estimate 20.current.value, we want to buy SPY. So self.set holdings. Set holdings SPY 1. Let's just test this out real quick. Okay. So you notice that here it's kind of weird. Like we had our initial order of 304, but then we have like this random one order, like one order. So why does this happen? Okay, it happens because when we set holdings 1, it just keeps trying to set holdings 1. So as the price of SPY moves around, this is like if it like goes up or down, like we might be able to buy like one more share, like. So that is why this one share is bought. But do we want that? What happens if we have like a brokerage that costs like $8 per trade? Like typically these days, most trade brokerages are free at this point, but like say for some reason you're using an $8 brokerage. And you don't want to spend $8 to buy one share of SPY, right? That wouldn't be very economical. So what we can do is add a Boolean check. So if self.portfolio dot invest, if not. So portfolio object gives us information about like the portfolio in general, and it can also give us information about specific securities. So if we aren't invested, if our portfolio is not invested in anything, then we set holdings to 1. And let's look at what happens. Okay, so now if we go to the orders tab, we only see the initial order. We don't see that extra dangling 1 share order. Okay, so now let's go. Okay, so what happens if we wanted to do this 520 SMA crossover for like a universe of securities, not just SPY? So let's go over that right now. So let's just delete all this. Okay, so let's just, okay, so to create a so what is a universe? A universe is a collection of stocks that we are limiting to ourselves that we want to invest in. So what are some examples of universes? Tech stocks is one such universe, as it narrows down. So like, think about it. There are like around 6,000 different stocks. But if we only want tech stocks, we narrow it down to like a few hundred, right? And so that's what a universe is. It helps us narrow down the securities that we want to invest in. And once we define our universe, we typically only invest in stocks in that universe. We typically don't go outside of that universe to buy different stocks. So let's create okay, so let's just, so add course. Okay, so to create, add universe. Okay, in QuantConnect, to create a universe, you have a, here, so what happens if you want to, okay, so what is add universe? So add universe. Okay, so selector. Okay, so you can have this. There's 2 ways to, well, there's 2 main ways. So selector, and selector is a function. Kind of weird. It's all C# stuff. Okay, so there's 2 ways. There's once you can have 1 function or 2 functions. So let's just go for the universe that only use 1 function. And when there's just 1 function, it's called a course filter. So let's just call this self.course filter. And then let's go to def. Let's create a course filter. And we have to make sure these match because we are passing this function in here to this add universe. Then we do self course. And what is course? A course is a C# collection like object that we can iterate over. Like, and let's just go over it. Let's just do C4C in course. Okay. Let's just do course Python list height equals C4 C in course. So let's just see what one of these course objects look like. So let's just 1C. So one course equals. Let's just take the first element here, and let's just put a breakpoint here, and let's debug this and see what a course looks like. So let's just type in 1 course and see what it's like. Okay, so let's just see what are some fields. So what these are is a QuantConnect course fundamental course. Okay, so the main thing we look at is dollar volume, which is the volume times the price. So show you like volume, but like we take into the price of the share, like it's like the amount of money of that stock being traded today. We have the has fundamental data. Yeah, I'm just gonna skip that for now. the price of the security, like SPY is like $400 or something. The symbol. So as I explained, okay, so symbol objects are like tickers, but the reason the symbol objects are used in QuantConnect is because tickers can change over time. Like if you think about it, change tickers. I actually don't know. I don't know any of the top of my head. So like. Well, you can see that like so the reason we can't use a ticker, well, like we'd prefer to avoid using a ticker, is because you can see that the ticker of some stocks can change right here. You can see here and then it changed here, right? And so that is why we use these symbol objects. Okay, so price. So okay, yeah. So why do we care about price? So a way to filter out penny stocks is we can like get all the stocks that are at least $5. If you want to do that. Okay. So it's just a dollar value. Okay, so what do we want to do? So let's just take the top 10 by dollar value. Okay, so top deval equals sorted. So sorted is a Python function that sorts a collection. Course pi list, so the collection that we want to sort. And then we can specify a key. And that is a function that tells us how we want to sort it. So lambda c, and then we want to sort by the dollar value, right? So we want to get the dollar volume out from our key uses the dollar volume to sort the things. So why should we use a lambda function? Like, doesn't it kind of look weird? What happens if we wanted to do something like this? C dot volume times C dot price, right? C dot price. This allows us to a lambda function allows us to make complicated ways of sorting things. Okay, and then we want reverse equals true, because this, when we do sorted, default it's by ascended, right? So it'd be the lowest dollar volume to the highest dollar volume. But when we reverse it, we get the highest dollar volume at the front. Okay, and then let's take the first 10, slice it, and then we need to return these. So right now these are course fundamental. However, course filters, universe filters expect a list of symbols. So what can we do? So return. That's a good question. So course is an iterable, it's a C# collector. Well, I don't think you actually, the problem is, so course is like a C# object. So there's this package called, right. So course is like, so the backend is in C#, right? And so course is like some C# iterable, right? But it's hard, it's kind of janky to like try to use like do this stuff like it's like a C# list, right? And well, like IEnumerable class, and it's kind of weird to use like C# objects, so we just make it into a Python list. Yeah, it's not a list, it's an iterable. It's like some weird C# thing. Yeah. However, like if we just do list comprehension, it converts in list. Oh yeah, there's nothing you can do. So like let's just, how about this? Like let's just do, we only want like price is greater than 5 to like filter out all the like the penny stocks. Let's return the symbol. So return x dot symbol for x in top 10. Wait, okay, so let me just go to GitHub. So you can see that these are mostly like C# files. Like the backend is all in C#. Like it gets converted into Python, but like the stuff is kind of like weird, like kind of weird because like it's not like native Python stuff. Okay, so this is a okay, so let's just go over. Okay, so let's just go over this again. So this is okay. So this takes all the all the like course fundamental that have a price greater than 5, and then we sort by the dollar volume. Then we take the top 10. Okay, so now let's go over to that simple moving average. Okay, so so this is a function called onSecurities_change, and it is called whenever our universe changes. So if one day, like there's like these certain like some like stocks that have like the highest dollar value, while another day there's a different set of stocks that have the highest dollar value. What happens is the symbols that were returned will change, and then once the symbols change, the onSecurities_changed function will be called. So self, and then we take one argument, change, and so for change.added securities, for security in change.added securities, we do something, blah, blah, blah. We'd have to, okay, so let's just create a dictionary called symbol data. Self.symbol data equals, so we usually want to use symbols for everything. So let's just do symbol equals security.symbol. And then self.symbol data. Okay, so why is the dictionary called symbol data? We're going to later create a class called symbol data. So why symbol data? Well, it's the data for symbol. That like clears that up. So symbol equals, okay, now what? We want the 5-day moving average and the 20-day moving average. So how can we represent that? Well, like we can create, so let's just create a class called symbol data. Symbol data. Definite self. Okay, so we want two fields, self.SMA5 equals self.SMA. So we're gonna pass in this QC algorithm object. And if you remember earlier, we called self.SMA to create a simple moving average indicator. And this simple moving average method belongs to this QC algorithm. And so when we pass in this QC algorithm, class, well, like it extends the QC algorithm class, we have access to the estimate. So algorithm symbol. Okay, symbol. So symbol, let's do 5 and then resolution.daily. Let's copy this. Estimate 20. Okay, equals symbol data, then self, and then symbol. And then so, okay, what happens if we want, okay, so there's actually multiple ways of doing this. Okay, let's just keep it like this. Okay, there's another way to do it. Like you can, okay, so you could, so this thing called, so like just, let's just say, I'll go over that later. Okay, so we have the symbol data. Okay, just ignore what I was saying. Okay, so on data self. Okay. Actually, let's have a function called rebalance. Okay, so let's just have this. Let's just do it monthly. So def rebalance. So how can we schedule a function to be called every month? Well, there's this thing called self.schedule.on. And then we can schedule a function. So time rule, no, date rules dot. Okay, so how do I know about this date rules and time rules? You can just look it up in the docs. Like everything, oops. So this is what I'm going over. So you can see there's different time rules, date rules, blah, blah, blah. So let's just do month start. Self dot time rules dot add. Let's do that like 9:35. Yeah, okay. And then self dot rebalance. Okay, so one thing you need to know about schedule universe is if you schedule a universe, you typically need to set the universe settings dot resolution equal resolution dot minute or resolution dot second or resolution. So why do we need to do this? Well, it is because we set it at this like 9:35. If we use something like daily resolution, it operates on a like everything is like called once per day, and all the data is received once per day. So that means we don't have more granular data. So it's just all called once per day. So say you have like some OHLC, right? Yeah, but it's for daily. But then you buy a stock at 9:35. Well, what price do you fill it at? Because you only have 4 pieces of information, the OHLC. But when you have it on a more granular level, on minute resolution, then we know what the OA bar of data at 9:35 is because we get more data every day. Okay. And so what does this line do? So self.universe settings, it is the settings for the universe we added here for all the stocks in there, the resolution that it operates on, how frequently we get the data for the stocks in this universe. We wanted to get data every minute. Okay. So momentum stocks equals, let's do something called dictionary. Well, like list comprehension. Hope you guys know what list comprehension is. I went over that in the last workshop. Okay, so let's get symbol for symbol SD. SD stands for symbol data. In self dot symbol data dot items if SD dot SMA 5 dot current dot value is greater than SD dot SMA 20 dot current dot value. Okay, so let's just go over what this means one by one. So we iterate over the key value pairs of the symbol data, and we take the symbols where if the corresponding symbol data for that symbol has a simple moving average of the 5 period, it's the simple moving average, is greater than the 20 period movement, simple 20 period movement. So so I didn't go over this, like, why is it dot current dot value? Well, this SMA here, down here, let's just go down here. So actually, let's just look at QC algorithm. Well, self.SMA, although it is a function, it returns a simple moving average indicator object. And it is And let's look at the simple moving average class members. But so we can also create a simple moving average. So like if we want to do self.spy SMA, another way we could do this is simple moving average. Yeah. Hold on. Oh yeah. Okay, so when we do it through self dot blah 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 self dot SMA, the QC algorithm backend automatically updates the indicator values. But if we have it like this is just like a blank. This is just a class. Like it just stores values. However, this isn't automatically updated. If we did this, we'd have to manually update it. So self.spy SMA.update. We'd have to manually update it with like values. So these are so the simple moving averages returned by this method are just a simple moving average indicator classes. And when we so what happens if we go, so to get the actual value we do dot current dot value. Kind of looks weird. Like why isn't it just dot value? Don't ask me. I actually don't know. So momentum stocks. Okay, so and okay, so let's do. So we want to set an equal weighting. So for self.set holdings stock, and then one by len momentum. And what this does is it just like allocates an equal amount of the portfolio to each stock. Okay, so let's just try this. Excuse me. Actually, I don't know if that will work. So what happens if I Okay, so what happens if our universe changes? So, okay, so we actually need to also go over the remove securities. And we need to remove it from our dictionary because if it's not part of our universe, we don't want to trade it. So self.symbol data.pop security.symbol and none. So just in case the reason if this symbol was not in here and we try to call this, we get an error. So however, if we just don't want to deal with it, like if nothing happens, if you don't want anything to happen if nothing's in there, then what this will do is comma and then return the default, and it'll just return this function. This method call will just return none. Like so, we don't have to handle that. It's just so that we don't. Okay, we see it does work. Okay, that's good enough. So what are some issues with this? So a problem is that these indicators, although although the updating these indicators, this process is automatically handled by the backend. These are empty. Like it doesn't go back. It doesn't retrieve historical data and automatically like make sure that they are ready. So what? It's just like on every new bar of data, these are automatically updated by the backend. However, at the beginning, they have no bars of data within them. So what can we do to address this? What we can do is request historical data. So let's just call hist equals algorithm.history symbol. So we want 20 days of data, and we want it on a daily resolution. And then we want to, so we get a multi-index pandas data frame. So like what happens if we have like multiple symbol then we'd have to index it by like either way. If typically we'd have multiple symbols, and then we'd have to like index it by one of the symbols and get like the OHLC data frame for that symbol. However, we are in this case we are only requesting data for one symbol, but we still need to index it by that one symbol to get the OHLC data frame for that symbol. So .loc symbol. Then we do for IDX row in hist dot. I just can't remember. Okay, it arose. There's like 20 million ways. Okay, so then we do self.sma 5.update IDX. Then row close. Self.sma20.update. So IDX. Okay, so like each row of these this data frame is indexed by a timestamp, like a datetime timestamp, and there's a OHLCV data, and so we want the C data, the close data. So while this step isn't absolutely necessary, we can definitely go without this. It's nice to have because it allows us to have our indicators ready immediately. Okay, so next, I want to go over like what happens if we don't want to change our universe so often? Like what happens if we only want to change our universe monthly? Well, to do this, we can do employer track. So let's just do self.month equals -1. Let's go to this course filter. So if self.month equals self.time.month, then we return universe.unchanged. And when we return universe.unchanged, it tells the backend that we don't want to we just want to keep whatever universe we had. And then we do self.month. Question. Okay, bye. Thanks for coming. Okay, then we check self.month equals self.time.month. Okay, this kind of looks weird. It's like, what exactly does this do? So let's just not look over this. So every month, we set the month to the current month. So right now it starts at 1. Is 1 equal to the current month? No. Well, actually, we want to not return universal unchanged. So let's do self.time.month. Yeah. Wait, no. -1. So -1. Is -1 equal to some month? No, it can't. It'll never be because month is an integer between 1 and 12. So -1 is not equal. Then we set self.month and then we recreate this universe. So let's just say we were in like July. So we go to July. So self.month is equal to 7 right now, right? Then we go to another iteration, go back here. 7, is 7 equal to the 7? Yes, return universe unchanged. So nothing changed. Okay, so let's say it's a new month. So self.month is still 7, while self.time.month is now 8, right? So is self.month 7 equal to self.time.month 8? No. Then we go down here, self.month is now equal to 8. And then this repeats for like 5 out of 7, like around like 25 days or so. Like 20 days or something, not including holidays and weekends. And so what you see here is that this logic makes it so that we only refresh our universe every month. And so why is this important? Well, it's important to like help reduce. It can help speed like. It can help speed up backtests as manually, but if we're like constantly changing our universe, then we keep subscribing, unsubscribing, keep having new indicators such as that. So it can slow everything down quite a bit. Let's just run this. Yeah, you can see that it works. That's actually about all I wanted to go over today. I'm just not. Actually, let's go to. Okay, so I have other QuantConnect videos like on using QuantConnect. So if you want to go over, I explain the fundamental, like one of these works. Yeah, this one. So this one uses QuantConnect to do fundamental investing. So if you want to know how to do that, definitely check that out. It's like factor. Okay, hope you guys all have a great day. That'll be it for today.